So we've had a bit of a look at the antiderivative, so undoing differentiation or integration. And we found that, generally speaking, we're going to increase the power by 1 and divide through by the new power. So this is called integration, and here is an example. And we've got some notation here. So this stretched out s sign is the integral symbol. And we're going to find the integral of 4x cubed minus 2x squared, all with respect to x. So a bit like differentiation with as x changes. That's the one we're looking at here. This is called an indefinite integral. There are things called definite integrals, but we will look at those in a later video. So we're just going to use this setup here, increase the power by 1. So it's going to become x to the power 4, and divide through by the new power. So it was 4 times that. If we divide that by 4, you just get 1. I'm not going to write the 1 in. And then increase this power by 1. So x squared goes to x cubed. It's already a 2. We're trying to divide through by the new power. So 2 divided by 3 is 2/3. And that's essentially it. Except, don't forget about that constant of integration, the plus c bit. You'll remember from the last video that if we were differentiating this bit, we would get this part here, even though we don't know what that number is. So we've got a few more examples coming up. Each time I'm just going to get you to pause and work it out yourself first. Here's our first one. Okay, so increase the power by 1. Divide through by the new power. Well, there's only a 1 of those, so it's 1 divided by 3. So I'm dividing this all by 3. I'm just going to write it like that. This goes to x squared. Increase power by 1. Divide that by the new power. 4 divided by 2 is 2. And that was positive. And then this is, well, there's no term here, it's x to the power of 0. So that's going to just go to x. So minus 2x. And did you remember that? Has it caught you out already? Or do you remember it? There we go. That's the first of those ones. Here's another one. It's possible that this one confused you a little bit because it's got r's and v's in there, and that's really where this, with respect to x, comes in. So, as far as we're concerned, the r and the v are just constant terms and don't really play much of a part. So r squared x cubed, we're going to increase that power. X cubed goes up to x to the power 4. And divide through by the new power. So dividing through by 4, well, that's an r squared. Dividing this all through by 4 gives us this. So the r squared doesn't change. You definitely aren't putting that up to an r cubed or anything like that. That's just a constant term. So this one, x squared will go up to x cubed. And we're going to divide through by the new power. Divide through that by 3. 6 divided by 3 is 2. And that was negative. And then this v was a bit like the constant term here, really. This is just going to become plus v lots of x, and then not forgetting our good old plus c on the end there. We'll just move up a little bit for the last one. So third one here. Right, it's actually a little bit nicer than the last one, although it is with q's. So with respect to q, increase that power by 1 and divide through by that. So 14 divided by 7 is 2. This is going to go up to 3q cubed. Divide that by 3, get 6. That was positive. And then this goes up by a power. It's a q at the moment, so it's going to become a q squared. And dividing through by the new power, so divide that by 2. And we still have a constant term, so it's still plus c as well. And that's it for these.